ground. Hopefully, you'll be able to climb on it.
Well, I think on this.
Alright. Ground, cool. Good one for me here. And so that's going to be our big, dangerous bolt.
It's only when it's long way up.
Extension cord. Miguel, I think, is there an extension cord under that? Kind of the, someone floating around.
This one? You gonna use this one?
Oh yeah, yeah, if I can reach in there. Very nice. Solid. Alright, and then is there some
That one's already plugged in inside.
Sure. Yeah, I'll just go. Let's see just because we'll probably teach you in a residential and other applications of paint will actually provide, some level of insulation so that can mess up. All right, good stuff.
The best hand.
All right, so we're safely grounded out here. Yeah, you want to try giving it a shot where we're going to connect that guy over there? Good question. Let's talk this through. What's our first test going to be? Open. Okay. We're in open. Line of load. All right. Which phase do you want to start with? Good stuff. All right. So I'm glad. Definitely looking at the breaker from the front. ABC left to right. So nailed it. Very good.
Starting with it.
We're doing 90 load.
You're in charge. All right. So let's go ahead and test this guy here. This is going to be our load return.
First cap.
Okay. All right, so we have our load return.
What's the test voltage?
16 kV. Oh no, 28.3. Yeah.
All right, cool.
Close to whatever.
Where you land for me?
So if you're doing line to load and it's open, it's gonna be down here, right?
Cool. Yep. I'm gonna agree with you.
Shouldn't matter
Thumbs
though, right? Because it's open.
Well, because it's open, we want to stay on that phase, right?
Stay in
In fact, we have our shorting leads. Remember, best practice says we should be shorting out the remaining connection.
Wait, is it because it's open that it is gonna go down here, or is it gonna go over here?
So just remember, what exactly are we testing when we do line to load? Right? We're testing across the bottom.
Okay. So because if this guy's smaller than this one, I can, like, it doesn't have to be.
Ours
I can
cheap.
do it.
It's ours only 99 cents. It works. That probably took like a week or two to design. Yeah, we took ours like 2 hours.
Why don't you guys rest up for a bit? So your question is, how do you know you're taking the right spot? So let's take it back to what are we testing? What's the purpose of this test? Line to load. Remember the test is called vacuum bottle integrity.
Test that the bottle actually opens and closes.
No, so not so much if it opens or closes. That's what the DLRO would be, right? The continuity.
Oh, okay.
But we want to check, will the bottle safely insulate?
Oh, voltage while being closed.
Yeah, will it withstand? Remember, dielectric withstand is okay.
Will it withstand voltage if it's open or closed,
Exactly.
right?
So we're going to ground all of the phases that are not under test. For safety. So anything that is not a phase. And because it's line to load, we're also going to want to do that. Line side and load side.
Oh, but those aren't getting clipped up to the machine.
not being
Like,
It's to any ground, basically any ground on here.
and is that so the voltage doesn't travel to the other ones, or?
We'll detect any kind of, so we're looking at line of load on the bottle,
Yeah.
right? But if the voltage or, you know, expected current path goes anywhere else,
Also, I can't put that on there, like on that.
yeah.
Okay.
Okay, cool. Alright, line of load. Alright, so, we're about a meter away from the bottom, okay? So this case, and hopefully you guys can see to some extent, we have our main power, our high voltage on, and our output, which is currently set to 0. Alright, we have our output, the big exterior looking one. One thing I want to note is, yeah, you guys came fresh off of the terminations looking class. Where are we seeing this particular wire? Kind of different components in here.
It's clear,
Yeah.
yeah. Right there.
So, yeah, in this case, we're seeing kind of those different steps. Like, I think of it like, you know, in the termination, any kind of you know, large voltage grading is going to be problematic, right? So in this case, there's like stress relief, right, and kind of steps to, you know, different voltage levels so that it's a smooth grading, right? All right, cool. So, what is our test voltage? 28.8. So for those of you who are kind of looking here, we're going to shoot for low scale, right? It's just shy of 29. We're going to do a close. Cool. And so remember, we're going to keep on the low scale, but if we see this kind of jumping, then we're gonna adjust on the fly. Everyone clear?
Sir.
All right. So nobody beat in between the big scary leads. All right. Power going on. High voltage on. Testing. There. So we're gonna see this go to that 28. All right. Now we're not seeing. I'm gonna crank this one down so we'll see it react. All right. So we're seeing the microamps going here. So we're about 7, coming up on 10. And so we're seeing as I increase the kV, we're seeing the leakage current kind of responding to it. We're coming up on 15, that's 15,000 volts, right? That's 20.
No, you're reading the bottom scale, not the top.
We're on the low scale. And you could change this, for example, if I go high, it'll just express it according to the top. So we're at 20, but we're still at 20. But say, for example, if you need 50 kV, then you can't use the low scale.
I'm only like halfway through. I just finished 2.
We're coming up past 20, coming up on 25.
It's a hard call whether I should finish it or not.
So we're gonna be just shy of 30, we're going 26, 27, 28, and let's just say just shy of 29 at about our 28.8. And so we're not seeing anything funky going on with the surface leakage or the leakage current, right? And it's pretty stable, right? Would you guys say this right here? And so chances are we leave it for a minute, nothing's going to really change. So we can, and it's already settled on a number here. So why don't you give a try for me? What would you interpret this number as?
0.22.
Yeah, because it's about a fifth of it, 0.23, right? Yeah, and so what's our multiplier?
1.
1, okay. So let's just say, if you want to express that in a different fashion, you'll see it's about 0.2 on that scale. So for resolution-wise, I think this is the way to go. So if it's 0.22 microamperes, the test form calls for, lucky for us,
2200.
they call for milliamps, or what do they say on your
Or is it microns?
micro. So you can actually write your 0.22 directly out, which is nice. And that means this is a pretty good condition, right? And
0.22 micro?
It's just been in 0.22 micro. All right, so am I just gonna drop out the machine?
No, slow it down.
Slow it down, crank it down. And for equipment like this that obviously is in a controlled environment, hasn't seen any proper action, so but
So you want to look at the soup type?
So it's 0.22 microamp?
man, go.
Whatever.
Alright, so we're off here. We're off
Green
here.
and close. Someone's looking.
Cool. Alright.
You shouldn't wait for the amps to die.
It'll have like residual amps.
Yeah, I was like you shouldn't wait for it to show 0 before you turn it on and touch it.
No, I think it would like take a while, I think, to get it. And we know the test set's
Oh,
grounded.
ground, so you touch it. Should be
Cool.
fine.
Alright, so that was the first one, A to or line of load on A phase. What's our next configuration? B phase. Cool. Anybody want to change up our configuration? So I'm going to start by shifting over our leads. All right, cool. Miguel, you want to swap these leads for me? All right. Yeah, I don't suppose you want to take your driver's seat for a ride? Sure. All right, good stuff. And like I said, you know, if you can tell, you know, your technical interview, you operated a high pot machine, and you basically just walk them through verbally what you did, and what, you know, what we're doing. Yeah, sign on the dotted line. You're hired. All right. So I'll look over your shoulder here, and I'll talk you through here. I'll also feel free to narrate as you go. So to reiterate, we're looking at, what is our test configuration?
At 28.8,
Yeah, 28.8 kV. Which phase?
B phase.
And what is our open-close configuration?
Open right now.
Yep, line of load. Good stuff. So you have my full faith here. Familiarize yourself with the machine. Obviously, it's your first time. Yep, zeroed out by default, which is good. So you'll be doing the same thing. You'll return this exactly as you find it. All right. Yep, that's the one under your control. Microamperes is what you're going to read.
Testing.
You feel the power of the big red button.
Do I say testing again or?
Yeah, as long as, and we're all aware we can cut
I'll
our
do it in
attention.
Spanish then. Testeando.
All right, you need a third language for the knob. All right, so you're seeing it ramp up. Which scale are you using? Top
This
or
one.
bottom?
Top
Definitely. All right, cool. So you're on the right track. Oh, you say top? Sorry?
Yeah, top.
Or you're actually on this.
Oh, sorry. I thought you were asking which one of these. That's why-
Okay, the top. Yeah, the top heater.
Where you
Gotcha.
use both.
That's right. Yeah, you're monitoring one while.
Truck out.
controlling the other. All right, I'm gonna call out for the audience what number you're currently at.
I'm 15.
Good stuff, and we're seeing some jumps on the bottom, but we're seeing that it is stabilizing. So again, control the rate at which you're increasing.
20.
Try and hopefully minimize the jumping on the bottom.
Yes.
Or 20. And it's settled, that's good. If it
Yeah.
settles, then it's good.
Right, that's why I stop. $23. Stages? Okay, there you go. $25. $29.
Yeah, that's it.
The other.
This and
Well, why
that.
don't you test our next phase for us next round?
0.25. No, it's 0.25. 0.25.
Cool.
0.25?
Yeah.
Micro ohms.
Micro amps.
All right.
Going back to 0.
Microamps?
So definitely slow to ramp it
Yeah.
down.
Yeah.
All right, you bottom down to 0. Yep, you cut the high voltage and then
There you go.
cut the main power. All right, good stuff. Cool. And so everybody has their next data set?
Sure.
All right, very nice. And so Mario's going to hop on for and so we'll change our configuration. What's our final setup for this particular breaker configuration?
That scared me.
Yeah. Line to load. All right, cool. All right, and yeah, Santiago had the question, you know, is the HIPOD going to be on the final exam? It won't be because, for example, this is the only breaker here that would even qualify for a HIPOD test, right? As we looked at the MTS, you know, that line that said, you know, integrity test or dielectric withstand test on a breaker would only be for your very large breakers, of course, right? You're not going to push tens of thousands of volts through those little guys, right? Unless you want a new breaker. Right? But so that being the case, you know, for an even field, you can expect bigger DLRO, basic inspection, those kinds of things. Question, Jeff?
Well, this one, because it's high voltage, the fingers, like it's okay to clamp on the fingers, it shouldn't.
Exactly. Yes, that's an excellent question. So we know with these contact fingers, they're pretty loose, right? And if you recall when we were performing the contact resistance DLRO ductor test on this, we know that this is a very poor, you know, connection, and there's no way, I mean, you're relying on luck at that point to get the 50% rule because you have such unreliable, repeatable connections. So that's why we would get onto the main stabs or even on here. But you're exactly right, because it's high voltage, to the tune of 28.8 kV, we're not too worried about it making that jump. So great question. Yeah, another good consideration. And what master over here? So, all right. Cool. So everybody seeing C phase, we're still in open position with all other contact ground. Give a thumbs up from the crowd. 1 meter away. All right. Cool. It's my turn as a Hulk. All right.
That's it.
Freedom.
Be the high voltage, right? That's it.
Feels power.
Then slowly, right?
All right. And what is our target number, Maureen?
28.
That's right. And so are we on the high or the low scale here? Which number are you reading?
I will read the top one.
This is pointing to.
Low.
Right. So and feel free to toggle between familiarize yourself with the equipment. We know we're on low.